So this is Trafficwerks. I'm Sean, this is Tom, and we're interested in climate change. So we see everyone just got these flash flood warnings, right? So I'm not going to say one flash flood does not mean climate change. But we are getting a lot of weird weather recently. Go to the next slide, please. So this is where I used to live, Austin, Texas. A lot of bad flooding in Houston as well. I have a friend that just posted pictures on Facebook that his whole house is just down and there's like hundreds of people are out. And this one anomaly does not show climate change, but we're seeing all these flooding on the East Coast, and we're seeing drought on the West Coast. And so what can we do about this thing? Well, we know that greenhouse gases are somewhat to do with climate changing. And one major contributor of greenhouse gases is transportation. Now, not a lot. We know that it's probably about 25% in New York, all the transportation, all of the greenhouse gases. But anything that we can do to decrease how carbon is going into the atmosphere is something that we can be proud of. So what we wanted to do is take transportation information from the NYC DOT and bring it into NuPIC and see, can we predict what's going on in the traffic? And if we can predict and see anomalies in the traffic system, then maybe we can reroute traffic to go around places where there's stops. If traffic is blocked up, then that makes cars are idling and having more greenhouse gas emissions. So Google Maps does a pretty decent job of this right now. If you go to Google Maps, you can see right now that there's red lines placed, and that means things are blocked up. Which is great, except that rush hour always blocked up. And so it doesn't really give you a lot of information to know that things are blocked up right now. Or rather, it's better to know what is really different from normal. And that's what we think NuPIC can do. We can see over the long period of time when traffic is worse than normal, and then and only then give notifications and say, hey, you should go somewhere else. So that's the idea. We didn't get that far, but we did get some information. So we went to the NYC DOT, went to their stream of data, and it'd be nice if they had a nice API that we could pull data from. Well, what they actually have is a CSV file, which would be nice if this was actually queryable, but this is real-time data. And there's no historical data. So what we've been doing to get data is for the past, when did you say, hey, just start grabbing cache data right now? Yesterday morning. So we've been caching data yesterday morning, every minute, pulling all this data, stashing in the system, and feeding it into NuPIC. Let's see, anything else about that data? So what we've got here is speed data, and we've got around different paths. So these black lines represent the paths that the traffic speed cameras in New York City show. All right, so all those black lines. So we pull all that data into NuPIC, and
we focused on just that little section right there that's lit up, and thankfully, and I don't want to seem mean, but there seems to have been an anomaly. So we did get to see that, and we did get to see how well NuPIC learns about that.
Do you want to rerun that?
Yeah, why not?
Okay, so yeah, it's not going to take that long. So
we don't have that much data.
But we do have a fair, we don't have, so the data comes in per minute. So we have a fair number of data points. We have about 560 data points. So when Tom runs this thing, we're going to see that, and this is really just for one of those lines. We actually got data for about 200 different routes, but this is just one of them. We kind of cherry-picked one that had an anomaly. So we see here going up and down, and again, this is really just for a very small period of time and just during the weekend. So what we would expect is we would get this data for weeks at a time, and then we would see traffic going up and down. Right now, we see we're at what? 2 o'clock. So then our cacher kind of crashed. And so that's what this whole line is. It ran out of memory. So we came in the next morning and said, Oh, that's not right. So it should be coming up. What's
Yeah,
it?
what you can't see is the other side of this.
Oh, okay, so there we go. So now we go and down at the bottom, you have to take our word for it, is the prediction. What is it? The anomaly.
Anomaly score and anomaly prediction.
So right about there, we got to about 500 data points. And then it said, hey, we could see anomaly. And right here, you see this huge jump right here, which is, it might be just around when the weather started getting
Yeah,
bad.
it might have been right when it started to rain. It's about the right time.
Right, and here we see this flat just until we get about 500 data points, and now we can actually start predicting things. So what we'd like to do, given that the data is still kind of weird, we can continue to run this thing, put up a Heroku instance, and just start keep going. Most of the code is there. In fact, the code to light up a little line on Google Maps is there mostly. And I think that it would be interesting to see this sort of thing after about a month and see how well it can predict. Anything else to add?
Just as an interesting aside, this sort of prediction didn't actually take all that much processing power. So we were actually able to run 120 instances side by side before we started slowing down and screwing around with the actual speed of it where we couldn't access it. So instead of graphing 120 lines, we chose one because it would be a lot easier to detect the anomaly.
Right. That's it. Thank you.
Thank you.
Yeah.
How frequently do you get the data?
It's sampling every minute.
Every minute?
Yeah.
So the data file is every minute, and we're grabbing it every minute.
Is it changed dramatically every minute, or is it a very slow changing over that period of time?
Yeah, go ahead.
You can see from the blue line that it's actually pretty consistent. And sometimes, like during rush hour, it'll change drastically. It'll go from like we graphed travel time instead of speed because we wanted something that would go up instead of something that would go down with traffic. Looks better, right?
Well, so keep in mind that this is just one of the paths,
Yeah.
which is fairly flat. The first one we did was more of a gradual up and down, so
Yeah.
it really depends on the path.
Yeah, well, and again, there's always the risk of oversampling. If the data changes fairly slowly compared to your sampling rate, then it's not going to work as well. But there's some sort of happy medium.
What we would expect if there was a really bad crash, that it would go up and up and up, and then it would go from maybe 20 to boom. And those are the things we really want to predict.
Like this, right?
Yeah.
This kind of thing right here. It might actually help to have other types of data sets in the prediction algorithm, like taking into account the weather, or if there's a concert or something else, but we didn't quite have the time to implement those. But in the long run, that's the kind of thing that we're going to want to try to implement into the algorithm.
I think the basic idea of not modeling traffic, but the anomalies in traffic flow, that's really cool. It's a nice idea.
Thanks. All right, thanks again.
Thank you.